Hello everyone. So in this video, let us talk about another problem from LeetCode. It's a medium level problem. The problem name is remove adjacent almost equal characters. Okay, now let us read down the problem statement. It says that you are given a zero index string word. As you can see here, you are given a string word. In one operation, what you can do is that you can pick any index I of word and change word of I to any lowercase English letter. So you can take any character and change it to whatever lower case character you want. Return the minimum number of operations needed to remove all the adjacent almost equal characters in the word that is string that you're given. So almost equal characters you have to remove. You just have to tell that how many minimum operations you have to do. What is almost equal? Two characters A and B are almost equal if they're equal or if they're adjacent in the alphabet. If they're adjacent, A and B are almost equal and A and A are equal. Okay, so let's take some example as well. So if you have A and A side by side, that is also almost equal, and A and B is almost equal. Okay, adjacent, you can say A, B, and C. So B and C are almost equal, and A, B, and also are almost equal. Like if they have an absolute difference of those two characters, let's say these two characters, is less than equal to 1, then they are almost equal. Okay, this is like the scientifically term you can say for almost equal. Okay, now how you can do that? Because first of all, I see that okay, you have an array of characters which we can tell as a string. Now let's take this as an example only. We have a 5 times. Okay. Now if we only have one character, if we just have one character, then it is almost fine because it is always fine. Only one character is fine. So we can always start from the second character, and we can compare it with the very initial character, like the character before it. If they both are very close, you can write on a function to check that if two characters are close or not, like almost equal or not. So it will just tell that whether the absolute values of both of these characters is less than equal to 1, then they are almost close. Okay. So you can find out that if they're almost close, what you can do is that you can somehow make it to another character. Let's say you can make it to X. Okay. If you change this character to any other character, you can also assume that this is changed, so this pair is fine. Because if you change this character, both of them was almost equal. You have to change them to not make it almost equal. So you can change them. If you change them, then you have converted to a particular character so that this pair is now not almost equal. So let's say you change this A to X. You have done one operation and you have changed this A to X. Now, if you change that, it might also occur that this was initially X. So you had create like bring it to X, but not there is not always a reason possible because you can change it to any character. So what you can see here is that if this is A, and if you change that, if you like change this character as well, if you change that, then you can also assume that you have fixed this pair as well. If this pair is also AA, but if you have changed this to X, if this is changed to X now, X and A will also not form a close pair. So this pair is also fine. So in one step, you have reduce the chances of this being a close pair and the next also being a close pair. Okay, so what in simple terms, which I was like when I was drawing some examples, very simple possible. You have to draw some examples and find out what's the possible outcome or solution can be. If you somehow change a character, then the pair that is this pair and the pair that is just adjacent to that particular pair, both of them will be sorted, both of them. So now you don't have to check for this pair. Like, so what we are doing for every character, we are checking it with the left character, just adjacent left character, that whether they are forming a pair, close pair or not. When I'm changing this, this pair is done. Like this is not now a close pair, and don't have to check the next one because we can always assume that we can change this to a somewhat other character so that this will not form a close pair, almost equal pair. Okay, so now we can jump to one step more ahead. That I will now compare from this A to this previous A. Okay, so now we can change that. Okay, let's take some example only. So let's say this is A. We first compare this with this. Okay, both of them are close enough. So let's change this to uh, X. Let's assume if I change this to X. Okay, so now if this is changed to x, this is not close and this is also not close. So we were initially here, my I was here, which I was comparing this with this. Now I will directly jump my I from here to here, not comparing this with this, because I know that it will always be fixed if I change this. So now this is I can again see that this is a close pair. So now we have to change this A as well. So we will change this also to X. And now this is fixed. So I can also assume that the next one is also fixed. So yeah, so we have done two changes, and we can see that we have got a string that is in any position. The two addition characters are not close enough, almost close. So that's the overall solution that we have to do. That's the code part. Let's talk about the code part now. So what we've done is that we have to find a total number of changes that we have to do. So this will be stored in total. Iterate over all the particular characters. Check that the two addition characters I and I minus one. The one the I am on and I minus one. And also I'm heading from I equal to one, not I equal to 0, because we can always assume that the first character, if it is exists, it is always fine. So if both of them are close, now this is a close function, we can just check out the absolute difference of A and B, like both the characters should be less than equal to 1, which means that either they are same or they have just one difference ahead. So they are close. If they're close enough, then we'll increment the total that we have to do one change. Whatever change we'll do, because there are 26 characters, we can make it to anything. But we can always assume that if we have changed that, the next one, that is, if we just move from this I to next I, the other pair that is there will always be get resolved. So we don't have to check that. So we can always increment my I plus plus. Like this is one increment, which means that skip the next one. And this I will always also will increment it. So which means that the next one will already be skipped. So this somehow optimize our solution, and we just have to find out the ones which pairs we have to change. We just find out this is a very good greedy solution, and in the end we just return the total. That's it. That's a complete logic. So this is the one only for loop that we have done. So it is O of n only. That is the time velocity. Okay, so that's the logic and the code part for this particular video. I hope you understand that. If you still have any doubts, you can mention on in the comment box of this particular video. I will see you in another one. Till coding, and bye.